Hello, welcome to class. This is the Unit 4 of our lecture series, PED 237, Measurements and Shape. Unit 4 talks about unit conversion and calculations. These are the course contents for Unit 4. Introduction. Many of the problems that you will come across in science and mathematics exercises involve change from one unit to another. This type of problem, in fact, is one you often see in everyday situations. You will recall that in Unit 2, units of measurements were extensively discussed. In this unit, procedures involved in the conversion of one unit of measurement to another shall be dealt with. Dimensional analysis, which is a general method of solving problems, which belongs to this category, will also be given attention. Problem solving and dimensional analysis. When scientists are confronted with problems whose solution appears obvious, arriving at a solution may not pose much problem. This is not the situation with more complex problems. The approach to these kinds of problems require breaking down of such problems into simpler problems or questions. For example, let's consider this. How many glasses of beer will you need for a party of 12 persons if each of the invited guests would drink 3 glasses of beer? Then, knowing the glasses of beer needed, the next question is how many bottles of beer you should buy if each bottle contains 4 glasses. Alright, if you consider this question, you will see that there's a little analysis that needs to be done. Because the example said you should plan for 12 people in a party, the number of beer they are to drink. How will you know the number of bottles to buy if each person is supposed to drink 3 glasses of beer and a bottle contains 4 glasses of beer? That's just what they are trying to ask here. The answer to this problem appears obvious, but let's look at the problem using dimensional analysis because the approach can be used to solve problems whose solutions may not be so obvious. Dimensional analysis, by definition, is a general problem-solving technique in which one uses the units of quantities to help one decide how to set up the problem. Right? So, we are going to use this example and understand how to handle problems such as this. Let's just go straight to the rules. We'll go to the rules. Steps for converting units by dimensional analysis. The following steps give a summary of the approach to problem solving by dimensional analysis. So let's see number 1. It said write out the desired conversion from the problem statement. Note the given units and the desired units. You want to convert as follows: quantity expressed in given units, convert to quantity expressed in desired units. I'll throw light on that. Then 2, obtain the conversion factor. The conversion factor is very necessary. Obtain the conversion factor. Write the equivalent statement. Then the conversion factor for the conversion from given units to desired units. You write the conversion factor as a ratio. Underline that and take note of it. So the conversion factor should be written as a ratio. It is very, very important. You write the conversion factor as a ratio with the given units in the denominator. and the desired unit in the numerator. So the given unit should be at the denominator, as it is stated. The conversion factor is equals factor times desired unit. Desired unit at the numerator, which is on top, while the given unit is at the denominator, which is at the bottom. Alright? As stated. Then this should be number 3, we wrote 4, so that's a rough error. So next one, perform the conversion calculation. Multiply the quantity in the given unit by the conversion factor. So quantity in given unit times factor times desired unit over unit given. We get a quantity that is desired, right? So let us now try the second part of the question. Following the above steps, knowing the classes of beer needed. They said we need, we have to get for 12 persons. 12 persons take 3 bottles, or 3 glasses rather each, which is 12 times 3. We know the number of glasses needed, which is 36. So 12 in 3 places is 36. Alright? Then calculate the bottles of beer to be bought. So the conversion factor needed is 36 glasses of beer convert to bottles of beer. So remember that each bottle contains 4 glasses, as stated. Each bottle contains 4 glasses. Then write the following equivalent statement, which is 1 bottle of beer contains 4 glasses of beer. Then the conversion factor from glasses of beer to bottle is 1 bottle over 4 glasses. 1 bottle of beer over 4 glasses of beer. So this is the conversion factor. Alright? The given is the one on top, the numerator. The desired is the one below, the denominator. So we have converted now from bottle to glasses. Alright? Therefore, 1 bottle of beer over 4 glasses of beer gives us 9 bottles of beer. And how is that possible? 1 bottle contains 4 glasses. If 1 bottle contains 4 glasses, then how many bottles are we supposed to get for 12 persons? Now there are little calculations that needs to be done there. So the party of 12 persons will require 9 bottles of beer. As stated, 12 persons by conversion factor of glasses of beer to persons. 1 person over 3 glasses. That's the conversion factor for the first one. 1 person over 3 glasses of beer. The conversion factor from beer to from bottle to beer is 1 bottle over 4 glasses of beer. And that will give us the bottles of beer needed. Alright? So if we simplify that, we'll see it here. 12 persons times 3 glasses of beer over 1 person times 1 bottle of beer to 4 glasses. If we do that conversion, we're going to have 12 times 3 times 1. Activating our calculator as usual. Calculator. Just a minute. Okay. So let's perform that. 12 persons times 3 glasses times 1. We have 36 over 1 times 4, which is 4. So 36 divided by 4. We are going to definitely have 9. So that's how we got the 9 bottles of beer as shown. Alright? So that is that. So the next one we are going to talk about conversion of units. Conversion of units. Alright? In the previous session we discussed on how to use dimension analysis and conversion factor to change from one unit to another. These Three basic steps were followed to accomplish this change. Write our desired conversion, obtain the conversion factor, and perform the conversion calculation. One of the most important types of conversion is from one metric unit to another. Let us now look at this type of conversion. Let's consider this example 4.1. How we can convert from one metric unit to another. How many milligrams are there in 7.71 gram? You already know before that milli means 10 raised to power minus 3. Recall that milli is the prefix meaning 10 to the power minus 3. That you've learned before. Go check other aspects of the module, you see that. So milli means 10 to the power minus 3. Therefore, anything in milligram, in place of milli, the n there, I will introduce the factor 10 to the power minus 3. Then automatically, when multiplied with anything given, our answer will now be written in gram. Alright? Let's see it now. 7.71 gram, or 7.71 milligram rather. How do we convert it to gram? I think that was the example. Okay, how many milligrams are there in 7.71 gram? Okay, so we are taking from gram now to milligram. Okay, gram to milligram. All right. So 7.71 gram times 1 milligram is equals 7.71 by the factor 10 to the power minus 3 gram. All right. Then it should be noted that the factor 10 to the power minus 3 at the bottom left hand side can be brought to the top as 10 raised to the power 3, which gives the answer 7.71 by 10 to the power 3 milligram. So I will exemplify this in our next sheet. So we are given 7.71 gram to milligram. What they did there, though there's some typographical errors there, what they did there was very simple. Alright? 1 milligram gives us 10 to power minus 3. 10 to power minus 3, just a minute. Gram. So that's how it's written. So 1 milligram gives us 10 to the power minus 3 gram because the factor milli means 10 to the power minus 3. So if 1 milligram is this, then X milligram gives us what? I think it's easier for you to understand like this. How many milligram? That gives us 7.71 gram. That's not what they're trying to ask us. So if 1 milligram gives us 10 to the power minus 3 gram, how many X milligram will that give us 7.71 gram? So if we cross multiply these, we'll see that we'll have X milligram times 10 to the power 3 gram. Because it goes this way, which is equals 1 milligram times 7.71 gram. Mind we are making X milligram and so the formula. So we have X milligram S milligram is equals everything here divide by 10 to power minus 3 gram. Alright? When we do that calculation, 1 times 7.71 is sitting as 7.71 gram divided by 10 to power minus 3. So what I simply did there was to say equals, you can say 7.71 times, since this 10 to power minus 3 is a denominator, if we're taking it to the numerator, it becomes 10 to power 3. The minus sign disappears. So it will become 10 to power 3. The minus sign is no more there. Alright? So that is how it is written. So that is 7.71 by 10 to power 3 milligram. That's the answer. Okay? If you want to solve further, we already know that 10 to power 3 is 1000. So we can now use our calculator to say 7.71 times 1000. That will give us 7710. That will give us 7710 milligram. Still a milligram. So that is how it is solved. So if you follow the solving like this, you get it correctly. Alright, so this is how it is done. That is exactly what the model did, but with certain steps they always commit. Alright? So, in continuation, so you will see that we give the answer 7.71 by 10 to power 3 milligrams. So that is what I showed you at the other side, how they arrived at what they got here. So that for the sake of exam, when you are having something of that nature, you should know how to solve it step by step. The model may not give us step-by-step solutions. That's the essence of the class. So let's consider example 4.2. The straight line distance from a town A in the southwest Nigeria and the town B, Benue State, also in Nigeria, is 2.98 by 10 to the power 5 meters. How far is the town in kilometers? So this one is simple. You are converting from meters to kilometers. You are converting from meters to kilometers. Just like say convert 2.98 by 10 to the power 5 to kilometers. So that conversion is 2.98 by 10 to the power 5 meters converted to kilometer. Note that 1 kilometer is equals 10 to the power 3 meters, which is true. That is 1000 meters. 1000 meters makes 1 kilometer. We check that on our previous lessons. Therefore, the conversion factor from meters to kilometer is 1 kilometer to 10 to the power 3 meters. So these are conversion factor. Then if we work with that, the conversion becomes easier. It becomes easier. Alright? And the correct power of 10 is obtained by subtracting 3 from 5, which is 2. Giving the power of 10 in the answer as 2. So I'm going to show us how this whole calculation was done in the next screen so that you understand it properly. So 2.98 by 10 to the power 5. 2.98 by 10 to the power 5. Power 5. Okay? So we are converting this to kilometer. To kilometers. Alright. Now, we already know that 1 kilometer is same thing as 1,000 meters. If this fact is established, and 1,000 is same thing as 10 raised to power 3, but we have 3 zeros here, so you should have known that before. We same thing as 10 to power 3. So, for those that may not have known that, you take note of that. It's 10 to power 3. Okay. Alright. Because the number of zeros we have here, 3 zeros. Okay? So, continuing with this, how do we now convert 2.98 by 10 to the power 5 to kilometers? Simple. If 1 kilometer gives us 1,000, therefore 2.98, okay, I think I should just copy it directly. Therefore, 2.98 will give us X meters, which is X meters. Alright? So, let's see how we resolve this. Just go to the other one. We cross multiply. If you cross multiply, it becomes, we are working with 10 to the power minus 3 here now. It goes with this. 1 goes with xn. Therefore, xn is equals to xn times 1 gives you xn also, which is x meters. Then we now have 2.9 multiplied by 10 to the power 3. I'll just copy that and drop it there. So, multiply by 10 to the power 3. So, from the laws of indices, since we have 10 to the power 5 here and we have 10 to the power 3 here, it's simply 10 to the power 5 minus 3. So, that's what we're going to have. Therefore, we use law of indices to sort this out. It will give us equals minus 3. Since we have it's just law of indices, you check up law of indices. We have same base, we subtract, and they are being multiplied together like this. We subtract the highest power from the smallest power, which is 5 minus 3. And that will give us 2. Alright? 5 minus 3 gives us 2. So I also will write the 2 directly now. So you have seen how I got it. 2. If I put 2 there, you will not be confused. So 2 meters. Is it meters now? Or kilometers? We are going from meters to kilometers. So it will give us 2.98 by 10 to the power 2 kilometer. That's what it will give to us. Alright? So 2.98 by 10 to the power 2. So going like that, you see it here, 2.98 by 10 to the power 2 kilometers. So that you will not be confused asking why did 5 change to 2? Or it was still there, why did it change to 2? So you just simply understand that there is a little law that was applied, which is the law of indices. It was applied there to analyze that too. Then in the same vein, the conversion desire is like the second one. I think there are 2 there. B. The volume of water in a household water reservoir is 1.35 by 10 to the power 24 milliliters. Also written as cm cube. Calculate its volume in liters. So to give here to us as milliliters, calculate it in liters. We already know that milli is 10 to the power minus 3. So it's always necessary to know the factors Once you know the metric factors, then you can easily solve the problems. So I'll advise you to look up metric factors and study very, very well. If I see factors, I see identify them, I know them because I've studied it. So I want you too to do same. So when you see any of the prefaces, a metric factor, you should be able to know what it stands for. Because most of them are, in fact, they are all constants. There's something they stand for. So milli is 10 to the power minus 3. Right? We saw kilo, not quite long that. Kilo is 10 to the power 3. So they are different. Milli is 10 to the power minus 3. Kilo is 10 to the power 3. So don't confuse yourself with that. So when we do the calculation, just as I've shown you a while ago, we are going to have our answer as 1. Okay, it's giving us at 24. Okay, it now be 24 plus minus 3, which will give us 24 minus 3, which will give us 21. So the factor there is 21. So our answer will now be 1.35 by 10 to the power 21 liters. So that's what it's going to give to us. So I will encourage you to go through the self-assessment exercise, go through this exercise and submit online. Go through the self-assessment exercise 1, submit online. And I also encourage you to conversion between metric units. You just try and go through the conversion between metric units. These ones are just like what we did. They are very, very straightforward and simple from one point to another. Okay, we'll be stopping here now for our time's sake.